Hello there, and welcome to part 3 of the Crosley 817 radio. As you see here, I added a terminal strip and put in 2 electrolytics. It calls for a 30 microfarad electrolytic at 350 volts. Of course, I have 450 because that's what I wanted to use, and that's all I had. I didn't have anything less than that, unless I went down to 160, which is obviously wrong. So I had a 22, and I had to add a 10, both at 450 volts in parallel. So that gave me 32 microfarads. So that's okay. 32 microfarads, 450 volts input filter capacitor off of the 5Y3. In one of my videos, I called this an 80. It's not an 80, it's a 5Y3. But in Sony Movie Studio 13, I cannot correct myself like I can in Windows Movie Maker with the text overlay. Can't do it, don't know how. So anyways, it's been suggested by one of my viewers, mentioned that these transformers are known to be undersized. And I really should check it out. Although the guy said it did, I guess, made a noise or hum or something. I don't know. So, the next step is going over here. I removed the electrolytic, which is here. It's only a 20 microfarad at 450 volts. It calls for 40 over here. So we'll put a 47 in here. It was tied up here, wrapped around this capacitor, which goes, I guess this is a capacitor, which I can't remove as I mentioned, to chassis, and then it's tied to this junction here, floating junction, which originally was down at the original electrolytic, which was in here. So I'll probably stick a terminal strip in there and bring those in. This is marked 15,000 ohms. I put an ohm meter across it and it read 20 or something. I don't remember now. I can't remember things. And it's been suggested that you're supposed to lift one lead. In my years of experience with testing resistors in circuit, yes, you're very right. I believe Dan of Cool Blue Lights said that, and then I answered his comment. If this resistor, in this case, supposed to be 15,000, it reads high, the circuit around it has no effect on it. However, if it read low, then you'd want to disconnect it, because the other resistors rather, and rest of the circuit is going to make the reading lower. But if it reads higher in circuit, it is higher. There's no two ways about it. Taking it out of circuit will either show the same reading higher or even a higher reading. Okay, so generally speaking, if a resistor goes to a grid of a tube, you can leave it in circuit, because unless the grid is shorter than the tube, which isn't going to happen, and you pull the tube out of the socket anyways, it's not going to affect it. There's a resistor here. So this resistor is high, and this one is body, end, dot. So I have to look on my chart, but body is brown, end is black, dot is orange. I gotta look it up. I'm sorry. I cannot remember my codes. I only know a few by heart, like brown, black, and green would be 1 meg, but I only know a few. So I got to look it up. But at the time I did look this up, and this is high. I did not disconnect it from the circuit because the fact that it reads high, the circuit has no effect on it. That very same method of testing, when a resistor reads high in circuit, the circuit around it is not affecting the resistor. Okay? It's been pointed out also on one of the radio mechanics videos that he made a year or so ago. So I've always done that. So yes, generally you want to unhook them from the circuit. But if, like I say, and I'm going to repeat one time more, if the resistor reads high in circuit, there's no point in disconnecting it, because the circuit around it is not influencing. It's not going to make the resistor read high. It will make it read lower if it's going to do anything. So the resistor would read high in circuit. It's going to read high out of circuit, and may even read higher out of circuit. So I can prove that. But there's no point in tying up part number 3 to show you that. When I get time, I probably will. So we got to dress this mess up here. We got to put a capacitor in, and it would probably be just as easy for me to tie in here. I don't think I'm going to be able to get the bottom end of this cap out. So I don't know if that's an electrolytic or what. It seems to look like one, but I really don't know. But it does look original. So anyways, we got to get this mess straightened out, and we got to replace these resistors. The problem is with my resistor stash, it's so hard because I have all half-watt resistors. I believe these are 2 watts, 1 or 2 watts. I think this is the 1 watt. I think this is the 1 watt. Body, end, dot. Brown, green, orange. I got to look that up. I don't know what it is. All right, on with the radio restoration. What we're going to do now, I took the electrolytic out, so what I'm going to do now is I'm going to power this up on a variac, and I want to see if the transformer puts out anything. The field coil and speaker are disconnected. This is where they go, right here. So I wouldn't need that to verify the transformer's putting out the AC. I just gotta trace out the wires for the high voltage secondary and put my meter on that and bring it through the dim bulb. Okay, your plates for the 5Y3 are pins 4 and 6, which I have connected with clip leads, and making sure that the leads don't short out here. I got my meter ready. I got to put it on AC, and I'm going to plug it in to the dim bulb socket, which is right up there. The bypass is turned off. In other words, we're going through the bulb, which is located way up there. We got the meter on. I'm going to have to hand hold this. You can see how fast the bench filled up. As soon as I get my terminal strips out and everything else, everything starts filling up again. So you'll have to go for a ride with me by way of camera. So we plug this in to the dim bulb. When I bought this socket years ago, when I built this is one of these child-resistant sockets, and they're an SOB to plug anything into it, or hard. All right. We're going to turn it on. All right, it just lit up a little bit. Let's see what we got. It looks like we got 558 volts on the secondary. Now we're reading between the plates. We're not reading from center tap. We will shut it down and do that next. The center tap is right there on the terminal strip. See where those two wires are twisted together? That's the way it was when I cut off that hanging electrolytic. Well, that center tap is now on the terminal strip. So we're going to turn off the power. We'll have to unplug it actually. We know the power transformer appears to be good. The bulb is getting pretty warm now. So we don't know if it's got shorter turns or not, because that bulb is pretty warm, and what it's probably doing is lighting up the tubes, and yes. So that would explain that. Transformer's ice cold because it's only been on for a very short time. We will unplug it now and we'll test center tap to each leg. So we'll remove one of these wires, put it on the center tap, plug it back in and see what we get. We should get half of 560 volts. Okay, I'm on the center tap. You can see the white clip lead here. And the other one is on one leg of the secondary of the transformer, which is right here with my fingers pointing. So that's pin 6. The other pin is 4. Okay, we're going to move this over to here. Now there's no tube in here, so we're not going to get any voltage on this. Alright, now we're on the other leg, and we're measuring from the center tap to the other leg of the transformer. So let's bring you back up here. You don't mind going for a ride, do you, with the camera? Dim bulb is just barely lit. 277 volts. All right. Looks to me like we're in luck here. All right, I stand corrected. That's not a flex resistor. That is the grid cap wire. It comes up to the chassis and goes to here. This tube right here. So I got a meter, ohm meter connected. Where am I here on the camera? All right, over here to my meter lead, and I get 0 ohms at this point right here. All right, so that's not a flex resistor. Okay, so we're okay there. We need to test these 3, 4, or 5 resistors right here. We'll do that off camera. It'll be taking way too long here. This mess right here, it's pretty firm, but here's what's going to happen. I take these out. These resistors have very stiff leads on them, so they make a good firm hanging tie point, so they don't hang. But if you put a modern resistor in there, it's going to be flexing all over the place, and it's going to be bad. So there's enough holes in here I can put a terminal strip in here, probably tack my ground on here like they had it, bring the electrolytic, which I'll use a 47 at 450 volts. It only needs a 300 here, and on the input it needed 350, but I'm going to put 450 in here. 47 to replace the 40, and then tie that on the terminal strip. and try to bring some of these down on it. But I've got to test these first. I got to go in the house and look at the schematic and jot some stuff down and come back out here. So we'll do that all off camera, of course. So that's where we're at now. It's good to know that the power transformer is in good shape. So we don't need to worry about that. It apparently is just fine. If there was any shorted turns in that, I think that light would have lit a lot brighter. Remember, it's lighting a little bit because it's lighting up all the tubes in the set with the exception of the 5Y3, which is out of the socket. I'll be back in a bit. This is the grid, what I call grid leak resistor. Grid resistor from pin 5 of the 6K6, which is grid number 1 to ground. Green, black, and yellow, 500,000 ohms. I looked it up on my cheat wheel. And it reads 658,000 ohms. So it's gone up high. We're going to clip it out. And we would normally put in a 470,000 because you're not going to get a 500,000 ohm resistor. And I don't think it's that critical, but it has gone up quite a bit. So we're going to replace that. Okay, I replaced that resistor. It reads 477,000 ohms. So there's a percentage there, of course. So that's a lot better than what was in there. Over here, pin 4 to ground, we have just below the yellow new capacitor I put in, you'll see two yellowish orange striped, apparently resistors. They go from the 6K6 green grid to ground. No idea, I'm sure they're resistors. Definitely look like resistors, but I've never seen anything like that either. In this age of a radio when it looks original, we're going to go and look on the schematic and on the computer, see what they are. They go from pin 4 screen grid of the 6K6 to chassis, both of them. I'm confused here. I'm having a hard time seeing in here because there's too many components in the way over here. It's very, very difficult. I'm at a kind of like a, I have a little problem here. I use my finger. I can't find out where that goes. All right. You see that? Those two resistors right there, I think they're resistors. I got the schematic. I'm going to put the schematic up on there and the parts list. I can't find them on the schematic. According to that, they go to the screen grids, pin 4. The problem with the damn schematic is it doesn't give you pin numbers. And as you can see on the schematic, it's very blotchy. I can't even read it. And this is supposed to be the better quality schematic, so I'm having a hard time identifying what they are. I think they're either capacitors or resistors. I think they're resistors. I thought they went from screen to ground, but they seem to go to screen, pin 4, if I'm not mistaken, to B+, down in here on the speaker socket. Where my finger's pointing is a 6K6, and this is the other 6K6. Pin 4, and I counted them 3 or 4 times over to make sure I'm reading it right, but I'm having a hell of a time seeing in there with all these components in the way. It's pin 4 as close as I can read that. And then we seem to have if that's the screen, we seem to have a capacitor, not this one here. I'm having a hell of a time getting in here. Goes from pin 4 over to the grid of the other 6 K6. And that would be an oscillator if that's the case. Or am I missing something? This is the grid. Resistor, where am I? Where am I here? Here am I. Okay. This capacitor I replaced, goes on the grid. This is 470,000 ohm resistor, was 100,000 over. But this goes to pin 4 to the grid. That don't make sense. I took it out exactly the way it was in there, hook and pinch, and I leave the leads on. That's another advantage to hook and pinch, is you cut off the component, the old cap or whatever, resistor or whatever, and leave the leads as long as possible, cut them close to the body of the old component. And that way you can definitely know where it went. But I'm confused here. So, I don't know what these are. So I'm at a standstill here. My problem with this is the schematic is very, very hard to read. It's just not clear. You can't seem to get a clear schematic. And this one, I got from Antique Radio Forum a link which is a lot clearer than any of the other ones I've had from like Nostalgia and so forth. But still not clear enough. Now I'm going to present the schematic and the parts list, which I did a screenshot on, saved them as a JPEG, and I'm going to put them in this video here. It's very hard. I mean, the parts are listed as, they give a number, a part number, but it's so blotchy that you can't read the part numbers, the symbol numbers of where they're located. So, right now, I can't even work on this yet. So I'm going to end part number 3 here. I can't do anything more until I get this mess figured out over here. And then I can close this opening here in the chassis back up again. Because I want to make sure if these are okay. And I think the resistors, the 2 orange things right there. Alright? Once that's done, and I don't think there's anything else in there. At least I hope not. I don't think there is. Then I can move on to this area. So, this concludes part number 3. And we're going to get in the house and do that. It's raining today. We need the rain. So let's get going on it. And what I'm going to show you now is the parts list and the best schematic I was able to come up with.